Hello there, I am Mr. Chuta, and we are continuing with our series of lectures on computer networking security. And today we want to look at the OSI reference model. Remember, previously we talked about the importance of communication models in communication processes. And the OSI reference model is one of the dominant models of communication in computer. Though I have to hasten to say that this model is more of a theoretical model as it is rarely used, but I think it provides the basis for the formulation of the TCPI model, which is now broadly used in most communication systems. So immediately after looking on the OSI reference model, we'll go on to look at the TCP/IP model and also make comparisons along the way of the two models, the OSI reference model and the TCPI model, so that we get to appreciate the similarities and differences between these two models. And the OSI reference model introduces the concept of layers in communication. Remember, in our earlier example, when we were given an example of a communication process, where we said a communication process in its simplest form involves the sender, the message, and the receiver. If you look at that communication process, you realize that there are three layers in the simplified form. That is the layer of the communicator, the message, and the receiver. That is one layer in one direction. Then at the receiver end, there's also the same layer, the receiver, the message, and the communicator. So that's the concept that the OSI reference model introduces to communication. So, for instance, let us look at this model with the example of sending a letter as another example. You realize that there are two friends who are communicating in this instance to send a letter. And the first friend will write his letter, that is at a higher layer, and you send the letter through the mailbox. The letter will be picked by the postal company, which is the middle of the layer. Then they will deliver the letter to the user. That is what the lower layers. And when you go to the other end here, what has been done in these layers will be repeated in these layers, now going upwards to the receiver. So you can see this is the layered approach that we are talking about when we talk about the layered approach to communication process. What this approach does, it tries to simplify the tasks or the processes that are involved in communication. For example, if we are to simplify so that we match similar processes, you realize that at the lower layer, the letter is sorted by the post office and put on a carrier to transport the letter. And this process is similar on both ends. At one end, the layer is being transported to the receiver. And if we are to look at the same process from the other end, the transporter is carrying the letter from the post office to the receiver. Then we look at the middle layer. At one end, at the sender's end, the letter is picked by the letter carrier from the box where you dropped it, and it's taken to the post office. Then you look at it at the middle layer from the other side of the user. The letters, when they arrive at the post office, they are sorted and they are delivered to the user's box. So this is what we mean by when we talk about the layered approach to communication processes. So if you look at this according to to the analysis that we've just done, you realize that there are 3 different activities that are being done at the sender side, and another 3 activities that are being done at the receiver side. And there's the task of transporting the letter between the sender and the receiver. That is done by the carrier for both sides. So you realize that there's something that is not obvious when you look at it, but which is similar to both ends. So you look at the middle part, the transporting of the layer from one end to the other. If we had not put this, you wouldn't even, maybe let's say, when you ask, if you were to be asked what are the processes that are involved in getting your physical letter from your friend to the colleague, these are some of the things that you would not have thought of, or that you would have missed in the communication process, but they don't appear obvious, or you won't even think they are necessary or important in the communication process. But the layered approach will ensure that we have a detailed approach to every process that occurs during the communication process. And it is also critical to note that as we use this layered approach, each layer will service the layer immediately below it. So a top layer will provide a service that is required by the layer immediately below it. And this is complementary. When it's at the sender side, it's going down. When it's at the receiver side, it's going up. So these layers, they complement each other's operation. So what is the OSI reference model? This is an open system or a set of protocols that allows 2 different systems to communicate regardless of the underlying architecture. So if we are going to use this to interpret this definition, you realize it doesn't matter your letter is written by a red pen on a black paper, or it's written by a white pen on a yellow paper. The OSI will allow your letter to get from one point to the other. Doesn't matter the technologies that you are going to use to write your letter, whether you printed it, whether it's handwritten, the architecture of writing the letter doesn't matter. But it will allow the two systems to communicate, or the different systems to communicate. So the purpose of the OSI model is to show or facilitate communication between different systems without requiring change that is in logic or in hardware architecture or in software. So it synchronizes and provides what I would say common ways of doing things, which each set of hardware or each set of software can adapt to, so that the communication process is successful. So we have to note that this model is not a protocol, but it is a way of understanding and designing network architecture that is flexible, that is robust, and that is interoperable. So these are the key features of any network. One, it should be flexible, it should be robust, it should be interoperable. And the OSI reference model facilitates that. And the OSI reference model has also enabled the generation and creating of various industrial and commercial standards that are being universally used in communication systems. So as we highlighted, that the OSI reference model is a layered framework for design of networks, which allows communication between different types of computer systems, and it consists of 7 layers, which are the application layer, the presentation layer, the session layer, the network layer, the data link layer, and the physical layer. So these are the 7 layers that make up the OSI reference model. And two key things that we can take away from this is that one, it's a layered architecture and it allows or facilitates peer-to-peer processes in the communication systems. So this is another depiction of the OSI reference model. So when we talk about peer-to-peer processes, you realize that at the physical layer, communication is direct. And if you look in this diagram, you realize that device A, sorry, let me try to. Yes, so you realize that at the physical layer here, device A here sends a stream of bits to device B through the immediate node that are available there. And at the higher layers, communication must move down through the hierarchy. So you realize here communication is direct, but when we are at the top of the hierarchy, communication will first go down here, then it comes here where it is direct, then it goes up again. That's what the peer-to-peer process that we are talking about, that it facilitates peer-to-peer processes. That we said here, 2 key things are there. 1, it's a layered approach. 2, to facilitate peer-to-peer processes. And the layered approach is facilitated by the passing of data and multimodal information through the various layers of the model as the communication is occurring. So the 7 layers of the OSI reference model can be thought of as belonging to various subgroups. And we can say that the layers, layer 1, 2, and 3, they belong to the physical layer. So that is they belong to the physical aspects of the communication process. So the physical layer, the data link layer, and the network model, they will fall under the physical aspects group. Then, so these layers 1, 2, and 3, we say they fall under the physical aspects of the communication processes, because they deal with the physical aspects of moving data from one point to the other. Then we have layers 5, 6, and 7, which are the session layer, the presentation layer, and the application layer. These layers are there to support user processes. So we can say they are user support layers. Then we have layer 4, which we can say falls into 2 subgroups. So layer 4 links, not falls, but links the 2 subgroups that we have created here, the physical aspects group and the user support groups. And their linkage is facilitated by By layer 4, the transport layer. So the work of the physical aspects and the work of the user applications are brought together by By the transport layer. So let's look at the various layers and the role they play in the OSI reference model. The physical layer coordinates the function requires to carry the data over the physical medium stream. So this layer deals with the mechanical and electrical specifications that are required for our communication to be possible. And the physical layer has various functions, which include the representation of bits on the physical medium. So the physical layer data consists of a stream of bits, which is what? Ones and zeros, which when you look at them, they need to be interpreted for them to be transmitted, and they need to be converted into a form that can be transmitted over a communication medium. So these bits need to be encoded into a form that can be carried over what? A communication medium. And the physical layer facilitates what? This representation of what? A physical medium. And it also manages the data transmission rate. How many bits are going to be sent per second over a communication what? Medium. So this data transmission rate determines what? The time a signal takes what? To travel over what? A communication medium. And then there's the issue of synchronization of bits. What the sender and the receiver sends or receive should be what? In the same format as it was. So this has to be synchronized so that it arrives in the same order it was sent at the same speed. So the synchronization of bits is also handled what? By the physical layer. So I want you to go and look at some of the issues that I've talked about. I listed there that include line configuration, physical topology, even the transmission mode, whether it's full duplex or half duplex. Those are what? Other functions of what? Of the physical layer. Then the devices that are available at the physical layer. Since we say the physical layer deals with the physical related characteristics of data communication. So these are the devices that are there with cables, repeaters and hubs, transmitters, etc. So I want you to also research further on other devices that I might have left so that you appreciate all the devices that support the physical layer functionalities in the OSI reference model. Then we have the data link layer. The data link layer is there to ensure that whatever has been done at the physical layer is transmitted smoothly without errors. So the data link layer ensures that the raw data that is emerging from the physical layer is packaged and transmitted in an error-free way. So it now looks at the issue of framing of the data so that it is packaged appropriately for transmission. So some of the functions of the data link layer includes framing, addressing, flow control, error control, and access control. I think, as you can see, these terms, they are more or less self-explanatory. But when maybe I can just say, in terms of access control, when we have two devices that are connected to the same data link protocols in a network model, it means that at one point or at each point in time, there has to be a device that is in control of the transmission process. So when you talk about access control, we talk about which device is currently controlling the movement of data in the communication process. So you can also go and write notes about the various functions: framing, physical addressing, flow control, error control, and access control. And some of the devices that you find at this layer with bridges and switches, so you also go and find if these are all the devices that are there. Then we go on to look at the network layer. So the data link layer oversees the delivery of packets between two systems on the same network. The network layer is a network model that ensures packets get from one point to the other. So it ensures that packets are delivered from the source to the destination. That's what the key role of the network layer. Delivery of packets from the source to the destination, be it across networks, across the internet, across across months. The network layer has to ensure that packets are delivered successfully from the source to the destination. From the source to the destination. And it makes use of formatting the data accordingly, so that it has the source address, the destination address, and the data packaged correctly so that it doesn't get lost. Remember, we talked about addressing modes in computer organization and architecture. And I want you to revisit those notes and see how they relate to the network layer. Are they related to networking, or we were forgotten, or they are related to internal workings of of the CPU? But what I want you to take away from this is that there is a concept of addressing of data packets in a network, so that data is delivered to the correct location. And some of the main functions of this include logical addressing and routing, which means this function, the routing function, automatically tells you that a router is a network layer device. With switches, with gateways, and some of the devices that are found on the network layer. Let's look at the transport layer. So this is responsible for the delivery of the entire message, the transport layer. It ensures that the fully segmented or packaged message location where it is supposed to be or to the relevant network host where the message is supposed to be delivered. So whereas the network layer in a network model oversees source to destination deliveries of individual packets, it does not recognize the relationship between the various packets, and it treats each one independently as though each piece belongs to a separate message, whether it does or not. And the transport layer in the network model, on the other hand, ensures the whole message arrives intact and in order. So overseeing both error control and flow control. So we say the network layer, it oversees the movement of the message from source to destination, focusing on individual packets. It doesn't matter, or it doesn't mind the relationship between the packets, but the transport layer is concerned that a message arrives in the order in which it was sent. So let's say I send a message 1, 2, 3, 4, 5. That message is supposed to arrive as 1, 2, 3, 4, 5. But when we look at the network layer, it will treat 1 as a separate packet, probably send it first, then it sends 5, then it sends 3. It doesn't mind if the message is going to arrive as 4321 or 424, 423, but the transport layer is concerned with that the message arrives as it was sent, so that is what it is understood. So it's important to know that one of the key functions of the transport layer is to ensure arrival of what? Of messages in a clear and orderly way if they were what? Transmitted. And these are some of the functions of what? Of the transport layer. So I think for now, let's end here. Then we continue with looking at the OSI reference model when we look at the session layer. So in order for our video not to be very long, I would end here on the transport layer, then start the next video looking at the session layer. Thank you very much for listening.